The final step before starting an analytics project is to shape the data into the right format for analysis. In this lesson, we'll explore the steps required to get data into an appropriate structured format. As we discussed in a previous lesson, applications like Alteryx, Tableau, or Power BI require your data to be in a structured, tabular format. However, your data might not originally be formatted this way. We'll consider how to get your data into this structured format. First, let's quickly consider unstructured data. We mentioned previously that unstructured data often comes in the form of text data. However, it can also take the form of other media such as images, videos, etc. For example, you might want to analyze news articles about a company. You could analyze the words used in the headline or the article to come up with a number that judges if the article is positive or negative. These numbers can be stored in a structured format. In reality, the techniques you would use to obtain this structured data are quite advanced, so we won't discuss their details here. Instead, we'll consider a different situation that you're more likely to encounter. Excel does not always use structured data, so you'll often find that the layout is not suited to analysis in other programs. In this context, shaping the data involves transforming it into a structured tabular layout that will suit that program. We'll look at a few changes you might need to make to get your data into shape. In Excel, we often store and analyze data on the same sheet. In this example, we have a sales dataset along with some calculations we've created using its data. In this case, the sales dataset only had 23 rows, so it probably made sense to do our analysis on the same sheet. However, if we tried to import this data into an application like Power BI, the summary statistics would also be imported, as these applications absorb entire Excel sheets. As a result, you should make sure that data and analysis are on separate sheets in your Excel files. A common issue with datasets created in Excel is that they can come in a pivoted layout. In this layout, information of interest is spread across multiple columns. For example, in this dataset recording survey responses, each row represents a person, and the responses to the questions are recorded over 100 columns. This data is often described as short and fat because there are a lot of columns but a minimal number of rows. A better layout involves unpivoting these columns so that the responses are spread across rows instead of columns. Here, we see that each row represents a single person's response to a single question. As a result, each person now has over 100 rows, but each of those rows is much narrower. This data is considered tall and thin. Fortunately, you can transform datasets from a pivoted to an unpivoted layout, or vice versa, using applications like Power Query, Tableau Prep, or Alteryx. We'll learn about why this layout is useful in our later lesson on databases, but for now, you should be aware that a tall and thin layout is usually preferable. Finally, you should consider other cleaning tasks that may need to be performed on your data. There are various steps that you may need to go through to get your data in the right format. In some instances, these could involve altering the structure of the dataset. For example, if you collected address data, you may prefer to split this into street address, city, state, country, and so on. This would help you analyze your data at different geographic levels. The mechanics for doing this vary between software applications, so we'll explain them in our other software-specific courses. There are other cleaning tasks which would not involve altering the structure of the dataset, but we won't consider them in this course. We've now learned how to shape our data before analyzing it. Data you obtain from external sources will often need some level of transformation to get it into the right format. Once this transformation is complete, your data should look a bit like a database, which we'll discuss in the next lesson.